Welcome to the Quality Excellence program to eliminate defects.
Why is it important? Why do we need to reduce risks and defects? Well, quality is critical to satisfy customers and keep costs under control. Superior products and services command higher prices, as we all know, delight customers, and significantly contribute to long-term revenue and profitability, making quality a key differentiator in a crowded market. Now, what is quality? Quality is a degree of excellence, the fitness for intended use to fulfill customer needs. So the fit, form, function, the 3F. So non-quality, therefore, is any deviation from the specification, from the customer's expectation, or from the established standard, such as a rejected proposal, a missed goal, overdue decision, late delivery, lost order, or returned package. Defects hurt profitability in the short term and erode competitiveness in the long term. Quality champions consider such defects as opportunities, improving bottom line profitability by eliminating poor quality. There are two quality challenges faced by any manufacturer and service provider in the world. Number one, reducing variability when customer requirements are not met. And two, reducing quality cost when customer requirements are consistently being met and process capability is firmly established. Solving these two quality challenges is an investment in the future and a top priority when failures erode profitability and undermine long-term sustainability. The Quality Excellence Program helps organizations like yours to achieve zero defect capability by addressing the four causes of non-quality: excessive complexity, process instability, ineffective control, and human failures. The program establishes the critical to quality parameters, the CTQs, that must be controlled to ensure consistent outcomes, while reducing the cost of poor quality, the COPQ, with direct contribution to the bottom line. The Quality Excellence Program is not only self-funding, but generates real savings and increases capacity from improved quality. Training your staff in process control and systematic problem solving during the rollout of the program ensures that critical skills are in place to continuously improve capability, cutting defect rates in half each year until quality excellence is achieved.
So how do we do that? What's the model? What we want is quality excellence. That's in the center. And there are strategies to achieve it. Number one, process simplicity. 2, process capability. 3, rapid detection. And 4, error proofing. We also need skills to execute such a program. There is the fault tree analysis, the causal factor analysis, the 8 human failures, and the root cause elimination process. On the foundation of the house, we have the 8 principles of total quality management, or TQM. And by applying the model, we will reduce variations defects, delays, and complaints. To make this model work, we need in the center the processes, people, and system to drive continuous improvement and achieve quality excellence. So let's talk about the foundation of the house. These are the 8 principles of total quality management. Total implies that all employees of an organization are involved to improve all processes from identified need to its fulfillment. Quality is the fitness for intended use. It covers all features and characteristics of a product or service to satisfy a customer. And finally, management refers to focused effort, providing funding, training, staffing, and direction to manage outcomes and achieve goals. So TQM is in the center. And there are 8 principles, and those are customer focus, effective leadership, people involvement, process centricity, system approach, continuous improvement, fact-based decision-making, and supplier relationships. Let's review those 8 principles in detail. In the center, TQM. So number 1 is customer focus. To understand their needs, to meet their requirements, and to strive to exceed their expectations. Number 2, effective leadership. This means to establish direction, provide training to build skills, ensure funding and staffing, so the program moves. People involvement. Involve everyone, not just quality specialists. Empower people so they can make decisions. And create a conducive work environment. Drive out fear. 4. Process-centric. This means establish process capability. Systematically reduce variations. And monitor performance to detect abnormalities. 5. System approach. And this means standardize processes, establish rules and limits, and address deviations. 6. Continual improvement. Challenge the status quo. Nothing is ever good enough. Evolve best known practices and raise targets faster than competitors do. 7. Fact-based decisions. Strategies based on opportunities and trade-offs. Base the tactics on projected return on investment, ROI. And make operational decisions based on performance data. And number 8, supplier relationships. Create real partnerships. Align strategies between provider and customer. And connect value streams. The next part of the house is about strategies. There are 4 strategies to achieve quality excellence. And we must implement them in sequence. So essentially, these are 4 steps. Number 1, process simplicity. It means to simplify the process, to lean out the process. To have fewer steps means lower risk, and that brings down defect rate to 10%, for example. From there, we establish process capability. So we improve the capability, CP, CPK.
it means less variability. Less variability means higher stability. And that brings down defect rate to 1/10. So from 10% to 1%. Step number 3, rapid detection. To detect problems in station for fast containment, so they are not being reproduced. It means fewer repeat failures. And that brings down defect rate again to 1/10, so from 1% down to 0.1%. Final step, error proofing. To protect the process, to prevent mistakes, to lower human risks of thinking errors and action errors. And that brings down defect rate not completely to 0, but for example also by 1/10 from 0.1 to 0.01%. All those elements together means we need to make the process simple, stable, fast, and safe.
We are now applying the 4 strategies to reduce defect rate by a factor 1000. Number 1, process simplicity. Defects increase with the difficulty and the duration of a task. Process complexity, therefore, is a cause of both. It drives variability and mistakes that result in defects. By changing the process, so to make it lean, so that fewer or simpler steps are needed, we reduce the probability of omitting a critical step or introducing uncontrolled variation in a procedure. Simplification reduces defects at their source. It must occur first because it's extremely difficult to change a process after it has been institutionalized. It is the main reason why simplification is addressed before variability, before speed, and before error proofing. Process capabilities, number 2. So defects increase with variability from unstable processes and uncontrolled interactions with the operating environment, such as the inability to hold tolerances. So variability is addressed using statistical methods, statistical quality control or statistical process control, to make processes more stable. It requires an understanding of the science behind processes, performing a detailed analysis of variance, ANOVA. Establishing process capability by controlling the characteristics of the outgoing product or delivery of a service, while eliminating the causes of excessive variations, brings down defect rate from around 10% to 1%. Next step, rapid detection. Defects increase with batch size and problem detection time. The longer it takes to catch a problem, the more often a defect can be reproduced. And that's a problem. So problem detection time is minimal when moving from batches to sequential processing, FIFO, first in, first out, using cells and flow lines. It provides instant feedback on infrequently occurring discrete events like tool breakage or mislabeled parts. So we find it right away. Separating unprocessed from completed work through one-piece flow, 1x1, prevents reproducing defects. It's not always possible, but it's ideal. Rapid detection brings defect rate down from around 1% to 0.1%. Final step, number 4, error proofing. Defects are also caused by human mistakes and errors, such as omitting steps, doing them incorrectly, or processing them in the wrong order. Mistakes cannot be controlled by statistical methods that focus on variability. So Six Sigma is useless for that. We therefore need to implement error traps, go-no-go fixtures, and inline validation checks. Because mistakes cannot be avoided and their consequences are often severe, they must be prevented. Protecting the process from human mistakes using error traps and validation checks brings defect rate further down from 0.1 to 0.01 or even less. So we are now building the second pillar of our quality excellence house, the skills. There are 4 critical quality excellence skills we need to build. Number 1, the fault tree analysis for rule-based problems to understand risks, delays, and defects. Then the causal factor analysis for event-based problems to analyze disasters, accidents, and breakdowns. And the human failure analysis to analyze errors, mistakes, and violations. And the root cause elimination process, such as PDCA, Plan, Do, Check, Act, the 8D, the 8 disciplines, or the Six Sigma process, the MAIC, Define, Measure, Analyze, Improve, Control, or any of the other popular processes. And this results into the fact that identify and eliminate causes allows us to lower risks and defect rates that drives higher quality and customer satisfaction. Problem-solving stages. It starts with a fuzzy problem, with many open questions, and we narrow them down to a problem statement, 1 sentence ideally. From there, we identify many potential causes and bring them down through root cause analysis to proven root causes. This opens up many potential actions, and we narrow them down to chosen actions. This opens up the possibilities for many different effects, and we measure and track them to get to proven effectiveness. And from there, we go into the sustain mode, to sustain the solution. Choose the right tool for the size of the problem. For small problems, use Plan, Do, Check, Act, PDCA. 1 form per factor. And for complex problems, the PDCA is not ideal. A common tool is the 8D problem-solving form, the 8 disciplines. Use them to address complex problems. Use 1 form per failure tree. By the way, they can be downloaded from the LeanMap website. Building the house creates an impact by reducing variations, defects, delays, and complaints. Eliminating defects reduces the cost of poor quality, COPQ. It's like an iceberg. On the top, we have the visible costs, such as scrap, rework, lost orders, delay to market, penalty payments, customer complaints, missed deadlines, warranty claims, cost overruns, and retrofits. Below the surface, we have the hidden costs, such as inaccurate information, double handling, misplaced paperwork, long lead times, expediting costs, grievances, difficult ways of doing business, long setup time, premium freight, overstock, improper installations, unsafe workplace causing accidents, late delivery, loss of goodwill and loyalty, so customers go elsewhere, revising documentation, low staff morale, recruiting costs of people who left, excessive work in process, overflowing inboxes, reputational damage, compliance failure, lost business, excessive employee turnover, equipment downtime, waiting and idle time, disgruntled staff or site, late paperwork, unnecessary emails, escalation meetings, unused capacity, inefficient design, planning delays, customer allowances, inspection and sorting, excessive overtime, engine engineering change orders. Those are all part of COPQ, cost of poor quality. Something we want to address and cut down. Quality management follows the 110, 100, 1000 rule. What does that mean? Well, reactive management means dealing with failures once they have occurred and costs already exploded. It means we measure cost over time. When we prevent a problem, it might cost us just $1. If we cannot prevent it and it's called in quality control, there is appraisal cost 10 times more, $10. If it slips through quality control, it causes an internal failure, it might cost $100. And if we ship it to a customer and we get it back and need to process it again, it might cost us $1,000. So, the later we catch it, the more expensive. And that's called cost explosion. On the other side, there is quality excellence. It means dealing with variability early to prevent costly failures later on. How does that work? We look at cost over quality. Of course, the higher quality we expect, the more expensive the prevention and appraisal costs. But it's still a lower portion or small portion compared to the overall. Then the higher quality that we have, the less internal failures we have, and the lower the cost of internal failures. And also, the less costly external failures we have. Compared to the cost baseline, that's the cost savings we will achieve through quality excellence. We are now using the driver tree or logic tree to address quality cost. And it consists of two components: the cost of conformance and the cost of non-conformance. So the good quality cost consists of prevention cost, such as planning for quality, training programs, design reviews, progress reviews, statistical process controls, and so on. And also of appraisal costs for capability analysis, performance tracking, inspection, testing, acceptance sampling, auditing, reporting, also for the supplies for inspection, and also the items that we destroy for testing, and the depreciation of test equipment. The bad quality cost covers internal failure cost, such as in-process scrap, rework, troubleshooting, repairing, re-inspection, retest after the rework is done, crashes, deadlocks, downtimes, premium freight to offset delays, extra stock to offset variability, buffer stock to offset yield losses, and design changes to correct issues and problems. And also downgrading of materials and goods so we can sell them. And also external failure costs, the most expensive ones, such as sales returns and allowances, service level agreement penalties, complaint and grievance handling, product recalls and replacements, warranty obligations, field service, shipping damage, absenteeism, turnover, legal costs from lawsuits, and loss of market share. So by addressing these topics, we improve quality. So this causes additional costs in prevention costs and appraisal costs. Those go up a little bit. But as an effect, as a positive effect, the internal failures and the external failures go down. So doing so, we reduce cost overall. We reduce the cost of quality. And that provides a budget to further improve quality. And this is the self-funding improvement cycle. That's what we want. Now it's time to apply what we have learned, to bring life into the house. Quality excellence requires the right mindset. Customers don't measure you on how hard you tried. They measure you on what you deliver. From Steve Jobs, Apple. Quality is never an accident. It is always the result of intelligent effort. John Ruskin. Quality begins with the intent, which is fixed by management. So it comes from the top. Edward Deming. Quality is the best business plan. John Lasseter from Pixar. So, quality is an investment in the future. That's the right mindset. Here are some golden words from the quality guru Edward Deming. It is not necessary to learn or change. Survival is not mandatory. Quality starts in the boardroom. That's where the direction is set. Quality is everyone's responsibility, not only the people who are touching the product or delivering the service. Every system is perfectly designed to get the results it gets. If you're getting more defects than you want, you gotta change the design. You cannot inspect quality into a product. So having this as a final gate is not a way to ensure quality. It just prevents defects from slipping out. Stamping out fire is a lot of fun, but it's only putting things back the way they were before. So the satisfaction from firefighting activities will not help you to drive quality. Whenever there is fear, you will get wrong figures. So make sure that it's okay to escalate failures and defects up. Don't hide them. In God we trust. All others must bring data. I like that one. Without data, you are just another person with an opinion. And you can't manage what you don't measure. Finally, defects are not free. Somebody makes them and gets paid for making them. Again, it's the system. Plan, do, check. the Deming cycle. So how do we put this into practice? We need a scorecard. The scorecard helps us to plan and measure against the plan. Here an example, it shows slow improvement, continuously red. Here we see stagnant, it's not getting better. Here unmanaged, goes up and down, so the actions are not effective. Here we can see 4 events, of which 3 were major peaks. Minor variability, so it's dancing around the target. An unstable process, this shows. And an opportunity, because at one day, in 1 week, we actually got a significantly better performance. So what did we do actually better during that week number 18? Another sign of instability. Another instability, and you need to ask the question, is this an event that happened during those 2 weeks? Or is this a drift? Another instability we can see here, so 2 major events that peaked. And we have 3 major events or periods during that time. And another sign of instability with 2 major events. And those are all topics for the quality review, to drill down and ask those questions. Here an actual case from the hospital. Incorrect insulin dose administered to 0.74% of the patients. And we need to ask why. The problem statement is 0.74% patients received the incorrect insulin dose. Why? So there are 3 direct causes. Incorrect sugar level measured, the correct dose was administered at the wrong time, or delivery system failure. Let's look at the measurement problem. This can be caused by sensor failure, computation error by the software, or transmitter failure. And we need to investigate those further. So the timing issue can be a timing failure or a timer reset. Why there is a timing failure? It's caused by having a programming failure, typing the wrong numbers into the computer, and not verifying it. The step was skipped. So why skipping the step? Either because overconfidence error, I know what I'm doing so I don't need to check, or the person was untrained. The timer reset can happen when there is a power outage and at the same time there is no backup. Why no backup power? Maybe because the person was untrained, distracted so not to connect the backup power, or simply careless. Delivery system failure caused by incorrect insulin computation, incorrect pump signal, or the pump failed. And we need to break this down even further. That's the principle of the logic tree. We have covered now the basics of quality excellence. And if you want to kickstart such a program, draw the logic tree first to understand the drivers of non-quality, so you can develop effective actions to eliminate, reduce, or control them. By doing so, you will bring defects and costs systematically down, improving profitability and customer satisfaction. And if you need help, we are here to support you with variability analysis, defect elimination, and program leadership. So contact us at expert@leanmap.com to book your complimentary consulting session. Or if you want to learn and build quality excellence and problem-solving skills, go to leanmap.com/academy to select and find the right program for you. I wish you great success tackling variations and defects. Thanks for listening. This was Jörg Münzing from LeanMap.